As differentiated network requirements emerge, network slicing is gradually gaining wider public attention. The technology can provide multiple logical networks on the same shared network infrastructure, accommodating different services, industries, or users. To implement network slicing, FlexE and channelized sub-interface technologies need to be used at the physical link layer. But how do you configure FlexE interfaces? Let's imagine a network consisting of two devices by way of explanation. Imagine that 4 types of services need to be carried on device A and device B. To ensure the SLA of each service, configure FlexE interfaces between the devices and set bandwidth values to 4 gigabits per second, 15 gigabits per second, 20 gigabits per second, and 30 gigabits per second. So if the rate of a single interface is 50 gigabits per second, each device requires 2 interfaces to carry the 4 types of services. Before configuration, however, there are a number of preparations that need to be made. First, ensure that the standard interface interconnection is normal. For example, check that the boards successfully register and that the optical module interconnection environment is normal. Next, prepare the interface-specific basic hardware license and FlexE license for the corresponding boards. Now query the interfaces that support FlexE capabilities on the devices. Here, we'll use 2 commands. In the command output, view the interfaces that support FlexE switching. If multiple physical interfaces need to be bound together, run the second command to check which interfaces can be bound to the same FlexE group. In this example, GE1/1/1 and GE1/1/2 are used on device A, and GE1/0/1 and GE1/0/2 on device B to carry services. After these preparations are complete, configuration can begin. Look at the configuration roadmap. First, activate licenses. Then switch the interfaces to the FlexE mode. Now configure PHY numbers and FlexE groups for the interfaces. Then configure the sub-timeslot granularity of a FlexE subcard, and set the configuration mode of FlexE client bandwidth. Finally, configure client IDs and bandwidth values. Now it's time for specific configuration. First, activate licenses. Activate license files, and then activate the interface-specific basic hardware license and FlexE license. Different commands are used to activate the FlexE license for different products. For example, the active port FlexE command is used for an NE40E, while the active port slicing command is used for a NetEngine 8000X. Simply select the corresponding command based on the device model. Next, switch interfaces to the FlexE mode. The bandwidth of a common interface is fixed. To flexibly customize the interface bandwidth, switch its working mode from standard Ethernet to FlexE. After the switch has been made, the interface is no longer a common physical interface. Now, it's a FlexE physical interface instead. Note that the name of FlexE physical interface starts with FlexE interface rate, and its number is the same as the number of the original physical interface. After switching interfaces to FlexE physical interfaces, flexibly customize them. Specifically, add 1 or more physical interfaces to a FlexE group and map the interfaces to multiple FlexE logical interfaces, also called FlexE clients, with customizable bandwidth through timeslot scheduling. First, specify PHY numbers for the physical interfaces to be added to a FlexE group. The numbers are used to identify the physical interfaces. While each physical interface added to a FlexE group must be configured with a PHY number, the phi numbers of the interconnected interfaces at both ends must be the same. In addition, the FlexE physical interfaces added to the same FlexE group must have different phi numbers. Now it's time to configure FlexE groups. Set group IDs to differentiate FlexE groups and bind physical interfaces to the groups. The same group ID must also be configured for the FlexE groups to which the interconnected FlexE physical interfaces at both ends are added. For example, add both FlexE 50G1/1/1 and FlexE 50G1/0/1 to group 2345. After adding all physical interfaces to a FlexE group, configure FlexE clients for FlexE physical interfaces and set bandwidth for each client. Before configuring clients and bandwidth, select the sub-timeslot granularity of a FlexE subcard and the configuration mode of FlexE client bandwidth as required. The sub-timeslot granularity of a FlexE subcard affects the bandwidth that can be configured for a FlexE client. For example, if the bandwidth to be configured is 4 gigabits per second, 15 gigabits per second, 20 gigabits per second, or 30 gigabits per second, set the sub-timeslot granularity to 1 gigabits per second. Otherwise, the 4 gigabits per second bandwidth cannot be allocated. The configuration mode of FlexE client bandwidth can be timeslot binding or bandwidth. In timeslot binding mode, a timeslot number is directly specified for a FlexE client to form a corresponding bandwidth. In bandwidth mode, a specific bandwidth value is directly specified for a FlexE client, and a timeslot number is automatically allocated by a device. Bandwidth mode is recommended because it's more flexible and convenient. It's the default mode because of this. Now configure FlexE clients. First, create FlexE clients. Specify the FlexE group that provides bandwidth for them. Specify FlexE logical interface numbers and set bandwidth values. In addition, configure client IDs for the clients so that the devices at both ends can identify them. To ensure that the FlexE clients on the devices at both ends can communicate, configure the same ID and bandwidth value for them. After configuration is complete, corresponding FlexE logical interfaces are generated. The first 2 digits of each interface number are the same as those of the corresponding FlexE physical interface. The third digit is the configured interface ID. After configuration is complete, run the command to check that the FlexE physical and logical interfaces are up and obtain the bandwidth values of the logical interfaces. In addition, run the display LLDP neighbor brief command to query LLDP neighbor information. View the neighbor relationship with the remote device on the local device. Configuration and verification of FlexE interfaces are now complete. To summarize key configuration points, configure physical interfaces, switch the common physical interfaces into FlexE physical interfaces, add the FlexE physical interfaces to FlexE groups, configure FlexE clients and corresponding bandwidth values, and map the FlexE physical interfaces to FlexE logical interfaces. Thank you for watching.